Greetings and welcome to my new calculus channel. My name is John Gabriel. So I'm going to deal with another question now, which is not as crazy as the previous one. And this one says, hey John, is there a way to geometrically find a distance of magnitude E? I'm pretty sure there is. I'm only curious, is there a known way? Same like with pi that you described in your previous video. So let's talk about this. Yes, there is a way. So for example, let's pull up another GeoGebra window here, and I'll show you. So suppose we do this. We say 1 plus x to the power of 1 over x, like that. So if we want to represent E geometrically, it will be this distance here. Okay, that distance to this distance. So this line here would be the antecedent, okay? Would be the antecedent, and this line here would be the consequent. Okay, it's as simple as that. So you would basically write E is the failed, oh dear, hang on a second. E is the failed measure of the ratio of this line here to this line here. Okay, that's E, and it's a constant. We realize it as a constant. That is what E is. Now, let's talk a little bit about magnitudes in geometry, because he also asked if you can describe the magnitude pi, or if there is a way to deal with pi. Yes, we normally think of pi as the failed measure that is realized from the ratio circle circumference to circle diameter. But now in geometry, all arithmetic is 100% accurate, and it's independent of an abstract unit. Okay, it works only on the physical unit. So if we choose, for example, pi, as I've done here, so pi will be this antecedent, this vertical line, which is 3.14 approximately, okay? And we could put in a value there. Let's do that. Value. So it says pi, but it's not actually pi. It's 3.14. And approximately, because there is no such thing as pi. And then, of course, this consequent is 1, right? So we could say that pi is the failed measure of this line by this line here. But look, it could be any other thing, all right? It could be any other thing. So if we drew a line here like this, okay, just like that, and then we drew a line parallel to that. So let's draw a line parallel to that. Like, so it says select parallel line and point, like this. Okay, so now any of these ratios here are equal to pi. That ratio there is equal to pi, okay? So if you put a point in there, like that, and you say, what is this here? This is G and this is F. So if you say y of G divided by x of F, you get pi, right? Doesn't matter where you are, okay? It can be over here, anywhere else, all right? So now what's happening here? There again, see? You got pi, right? Pi. It's because I'm not on the axis exactly. If I'm on the axis exactly, then it's pi, right? And try to get it on the axis exactly. Do you see that? So anywhere along here will be pi. That's because In fact, there's a better way to do it. Here's a trick. Watch this trick. I could put that point there, and then this will be h, and all I'll do is I'll say x of h, and it'll always be correct. Okay, so there you go. You see there? Here's this value. Okay, it's always that value. So you could represent pi as a failed measure of 4 to this distance here, or anything else you like, okay? Any parallel line to that will represent pi. Now, what about any other ratio? Let's take this ratio here. I've got a ratio of 4, 3. Can we change this consequent 4, 3, or the ratio, so that the consequent is the same as pi? Well, we actually can, and here's how we can do it. Again, we represent the ratio by closing that line there, or closing those 2 points, and then we say, let's do a line parallel to this one. So say parallel line, that and that, okay? And then, of course, all we have to do is move it there, like that, and this distance to this distance is 4/3, okay? Definitely is 4/3. And if I just have to just get rid of that, put a point there, like that, and then get that line back, okay? Now, so what I'm telling you now is that no, I don't want to move that. That should stay as is. Okay, so what do I do with this point now? I should have put it somewhere else. Anyway, so if you take the y value, 1.333, and divide it by 1, that's what 4/3 is, isn't it? Agreed? And so anytime you want to work with ratios in geometry, I could, for example, I could make, so let's put this at 4, 3 there, like that. And I could make either ratio consequent equal to the other. And of course, the antecedent is affected. Now, instead of me carrying on and telling you all about these things, I've written a fantastic book, article, in fact, for you to study. Here goes. So if you go to my website and you type in theory of fractions, in fact, I'll place a link to it. Here, this article here, it explains all these brilliant facts to you, stuff which no mainstream professor knows about, because they're all fucking morons, like most of you. Okay, so this will tell you everything you need to know about ratios and how we got arithmetic, and then how we went on to get algebra and number from geometry. Very important stuff, by the way, and I am the first human in human history to reveal these facts. No one before me knew these things. Okay, I am the first, the great John Gabriel. So I advise you and recommend that you study these things. I'll place a link to this article, and you'll get a much better idea what all these things mean, okay? Instead of me sitting here having to explain it to you. It's all being done. If you're not already a subscriber, become one, click like, you know the drill. I'm John Gabriel, and this is the New Calculus channel. Till next time, goodbye.